Find the derivative of f of x equals x times the square root of x squared plus 16, then evaluate f prime of 3. F of x here is the product of two different functions. We have x multiplying the square root of x squared plus 16. The first thing I'm going to do is rewrite that as a fractional exponent. It's first power, second root, so 1/2 power for the derivative. Since we have a product of x times that, we will then have the product rule to use for our derivative. The derivative f prime of x will be the derivative of the first function, that's the x, the derivative of that will be a 1, times the second left alone, so x squared plus 16 to the 1/2, plus the first left alone, times the derivative of the second. Now that's a power rule, so we'll bring the 1/2 down. We'll leave the inside alone. We'll subtract 1 from the power, but let's call it 2/2. And then we multiply by the derivative of the inside to complete the chain rule. Don't forget that that will give us a 2x there. Now everything is multiplied here in this second term. So I can move this 2x to the front here with this 1/2 and that x and multiply all of those together. The first term is 1 times, we don't need to write the 1, x squared plus 16 to the 1/2. The second term will be, we have an x and a 2x. If they multiply, that's 2x squared. And then that will be over 2 for the 1/2. And those 2's can cancel. And we have x squared plus 16 to the 1 minus 2, which is negative 1 over 2. Now since we have a negative exponent, the next step is to move that to the denominator. So f prime of x will equal x squared plus 16 to the 1/2 plus x squared over what will now be x squared plus 16 to the positive 1/2. It moves to the denominator. The x squared stays in the numerator. It's not a negative exponent. Now at this point we can get a common denominator between these terms so that we can combine them together to make the derivative a little bit nicer looking. We need to multiply that first expression by an x squared plus 16 to the 1/2 over an x squared plus 16 to the 1/2. So it matches the common denominator with the second fraction here, which will be x squared over that common denominator. Now if we multiply these together, you add their exponents, and 1/2 plus 1/2, 2/2 or 1, will mean we'll end up with x squared plus 16 to the first power. So what we have here is x squared plus 16 to the first power plus another x squared for the second fraction, and all of it is over that common denominator of x squared plus 16 to the 1/2. So our f prime of x can now be written as, in the numerator, let's add the x squareds together. So we have 2x squared plus 16, and then in the denominator that 1/2 power can also be written as square root to the first power, just square root of x squared plus 16. One other step that we can do, there is a factor of 2 in the numerator. It's not required to do this unless you need to make it look like this form. But we can factor a 2 out, and maybe we'll write that version as well. Now that we've found the derivative, let's go and evaluate f prime of 3. F prime of 3 will be, and I'll just make use of the second version, the factored with the 2 in the numerator, but it'll work out the same either way. 2 times 3 squared plus 8, plugging a 3 in for each of the x's, over 3 squared plus 16. So 3 squared is a 9. And we'll have that 3 squared in the denominator as well. In the numerator, 9 plus 8 is 17. In the denominator, 9 plus 16 is 25. So in the numerator, 2 times 17 is 34, and in the denominator, the square root of 25 will be a 5. So we end up with 34 over 5.